There's a 25 horsepower Baldor motor there that runs the cat pump. If you needed to replace it, the wiring is on the inside of the pecker head cover. The GE motors, again, are 220 volt single phase for this unit. If you call and you order a GE motor, it's going to be shipped out wired for 110. You have to pull the orange and the white lead off and change the pegs on the inside of the GE motor to wire it for 220. If you don't and you put it and you do install it, you're going to burn it up. The pre-soak heaters, 9 kW or 4.5 kW. The larger pre-soak heater is usually used in the colder climates. The 4.5 is the standard one that we use most of the time. And that's about it for the miscellaneous parts and pieces. Okay, let's go over, this is the electrical control panel. We're gonna go over we're gonna follow the outline again. We're gonna go over the incoming power, where to hook things up. So the first one is the incoming power. We got 200, when you're doing the install, you're gonna have your electrician run 220 volts, 3-phase, into the top of this disconnect switch. The 110 volt will go into the auxiliary switch, which is located on the left-hand side of the disconnect switch. The hot for the 110 volts will go here onto the left-hand side. The neutral will go to the neutral bus, which is left of that. The ground will go all the way back over to the grounding bar. Tell the electrician or make sure that when they're doing the install, that they come into the side of the cabinet or the bottom of the cabinet. If they come into the top of the cabinet and you have a leak in your equipment room, the problem is most of the electrical fittings will leak and allow water to drain into around where the threads are into the top of the disconnect switch, which is going to cause a short, and this is going to go out. And so it's always better just to go into the side from the very beginning. Have the electrician run a ground wire from the breaker box grounding bus all the way over to our grounding bus so that we get a good solid ground. The metal conduit between the two boxes is not a good ground. They don't try to do that much anymore. They usually don't mind pulling a ground wire, just make sure that they do. And run all of your ground wires over to your grounding bus. When you're doing the install, you're gonna have to pull the 12.5, the 12.3, a 4.4 SO cord if you have onboard blowers. Every one of those will have a green ground wire in the SO cord. Tie those in to the grounding bus as well. Okay, once you've got your power hooked up, 110 and 220 3-phase, your 3-phase, 220 3-phase power will come out of the disconnect switch and into the top of the cat pump contactor, as well as it comes out and goes over here and supplies 3-phase power to this breaker. This breaker, it protects the heater, the pre-soak heater, as well as the gantry. When you tie your 12.5 SO cord from the gantry and you need to get 220 volts using the 12.5 out to the gantry to run the motors, you need to tie that 12.5 SO cord into the top of the pre-soak contactor. And that's very important that you do it that way because this contactor is made to accept 2 wires. It has a place up here, it's dual ported, so that these wires are in one port and your 12.5 SO cord will go in the other port, so that we're into code. As well as the cat pump contactor is built the same exact way, and for your 4.4 SO, the blowers, you use a 4.4 SO cord, which we supply, and it goes into the top of this one. This is protected by the breaker that's mounted on the wall, the 100 amp breaker. The gantry is protected here by this breaker. This breaker is the 220 volt single phase breaker, which protects the GE motors. You got 220 volt single phase coming out the bottom of the breaker, coming over here and going into the top of this contactor. This is a 3-phase contactor. We're only hooking up 2 wires, using it as a single phase. You could, if your point's burned out on one, swap the wires over to there, move the bottom to the same, and it will work. These contactors, like I said, operate the GE motor starter. You get your output on this orange wire to pull the coil in, the 24-volt coil, from this ROC16. Every contactor in this panel, except for this one, has a 24-volt coil. The cat pump contactor has a 110-volt coil, and it comes off of the ZOC16. We use a 110-volt coil on this contactor because it's a lot larger contactor and you need a lot more power to pull this large of a contactor in. This is the only contactor with an overload as well. The overloads are set from the factory on about 85. If you have 208 voltage, you ought to put an amp meter on because you're probably going to have to turn the amperage up a little bit. The motor should be pulling somewhere between 65 to 67 amps with 220 volts three-phase. We have put in the terminal strips, terminal 1, 2, and 3, and this is where you're going for your 12-3 SO cord to supply 24 volts AC power out to your gantry. You're going to hook up your 12-3 SO cord to 1 and 3 or 2 and 4 on this terminal strip. This is your 24 volts hot. This is your 24 volts DC, negative and positive. The blue and the brown wire on the gantry as well as the pumping plant is always used for 24 volts DC, negative and positive. Like in the beginning, you need a DC negative power source to serve as an input to the ID16. That needs to come from here. You cannot use another DC negative power source to give me an input. It won't work. Here's 110 volts hot and 110 volt neutral. It is covered by a piece of cardboard for protection of yourself. If you're going to wire an auto cashier up to this panel, we have given you the place to do that. If you want to wire the auto cashier up and have a dedicated circuit from the circuit breaker, that is fine as well, but you still have to run the cycle wires in your reset over here to this pumping plant. But if you're going to wire it up here, here's your 110 volts hot, here's your neutral, here's your ground, and your auto cashier reset. The red line and the program is made defaulted to work with a Hamilton. A Hamilton auto cashier reset, when the wash is through, we send a signal for 2 seconds to the Hamilton, to the inhibit signal, which is the last relay, so that we tell the Hamilton we're done washing the car. The Unitech, as well as the Entry Wizard, they have a wash in use signal, which in the red line, and we'll go over that in a little bit, you will have to toggle it to use that kind of auto cashier so that we swap the way that we send the reset. So that instead of sending it a reset at the end, when we're washing, we send it a continuous signal. And then when the wash is over, we take that signal away. So that's the auto cashier reset. As well as you have your 24 volt DC negative to send out to your auto cashier to use as your common to come back for your cycle wires. You have cycle 1, 2, 3, and 4. You will use the DC negative, and if you're using a Hamilton, it's the simplest. You will wire it to 1, 3, 5, and 7 for your relays. When the relay pulls in, the DC negative voltage will go through the relay, back out the wire, and come over here and give me an input on that signal, on that cycle. If you have ordered the scrolling sign or the wizard message sign, you will wire it down here in the bottom. If you haven't ordered it, those wires will not be there. This is an ROC08. You will receive this component when you order the option of the doors and or the sign. If you order either doors and or sign, it is wired for both. Terminal 2 is where you will get your 24 volts DC negative and positive to power up your eyes. Your transmit eyes only need 2 wires, the positive and the negative, because it's just a light. Your receiver eye needs the 3. They need the positive, the negative, and the input eye, or the transmitting wire. You will tie the treadle eye into 3 and the entrance eye into 4 from your receiver eye. You also have 24 volts neutral, spot-free rinse, and a digital timer. The spot-free rinse is 7 and 8. There's a relay over here, and we pull this relay in. When you send an output or when you have spot-free designated to go on that recipe, we're going to send an output from the ROC16 to 24 volt AC output. We're going to pull this relay in. What that does is that allows you, whatever power you put on 7 is going to come out on 8. The reason we do that is because of the Super Saver. The booster pump, when you order a Super Saver and a Wizard, you get a booster pump. If you ordered an RO system, it's mounted on the Super Saver. That booster pump, the output to turn that booster pump on comes off of the Omron inside the Super Saver. If you take 24 volts from here and you try to energize the input on the Omron on the Super Saver, a lot of times it won't work because of the phasing. You don't have a neutral. So what you got to do is you have to tie the neutrals together from the Super Saver to this, which if you have a swipe and clean, it will cause a problem. You could get a phasing problem on your neutrals. So we quit doing it that way. We installed the relay. And so the way you want to wire that is you want to pull 24 volts hot from the Super Saver, bring it across the room, go into 7 and or 8, it doesn't matter. Take the other one, the other wire from 7 and or 8 and go back to the input, to the proper input on the Omron computer. The proper input for that computer can be found on the Super Saver sheet that will be inside the door that they give you on the input and output sheet. If you order a booster pump from us on your AKO and you do not get a Super Saver, or you're not purchasing an RO system, but you do have the booster pump, there's going to be an extra contactor in here now for spot-free rinse. And it's going to be when we do the AKOs and we write down how to build the units, I write on there a spot-free rinse motor starter. Now, if you don't order the booster pump from us, you don't get that. And so you're only going to get that if you don't purchase the RO or a Super Saver. And so if you get the booster pump, it's not wired, just the contactor is there, and you got to bring the hot wire will be there to run the booster pump, but you'll have to wire from the booster pump over to the contactor because I don't know where you're going to place the booster pump. There's nowhere here on the stand to place it, and so a lot of times they'll either bolt them to the wall or bolt them to the floor somewhere in the equipment room. And you'll just flex over to that, or however you want to do it. This terminal strip, on this terminal strip, you have a digital countdown timer for freestanding blowers. There's a little timer that counts down the time. On the Dixmoor digital countdown timer, terminal 3 and 5, they wanted a dry contact. And a dry contact is a contact with no power on it. So what we've done is we've put a relay in as well. And so when the blowers, we send the output for the blowers, we pull this relay in, which gives you a dry contact. There's no power on this relay. And if you go from terminal 3 and terminal 5, you'll bring 2 wires over and go to 9 and 10. That will make your little countdown timer sign work a lot easier. Is there anybody in here that's going to be doing doors? You'll be doing doors? Okay. When you order the door option, you will get this card. Your doors will be wired here. This is where you will wire your doors. Inside the equipment room, there will be a box with 2 buttons to open and close that specified door. When you pull the cover off, you need to run a 3-conductor cable from those buttons over to here. When you pull the cover off and access the back of the buttons, one is a common wire, and it will jump between the close as well as the open switch. That wire will go over here to the entrance door common if you're working on the entrance door, or the exit door common. And we basically do the same thing as if you're pushing the switch. All we do is we use their power. We come over here, we wire it over here to this common, and when it's specified, we pull this relay in, sending their common back over there to open or close that door, just like if somebody was pushing the button. That is the simplest way we could come up with doing it. And so when I've done doors, I have just drilled a hole in the side of the box where the buttons are and tied right into the back of the buttons. It makes it for a real simple installation. And it's a lot less confusing. Then that way also the doors work as they wanted them to for the factory. If some of the doors have an Omron PLC that they use to make the doors operate, and you don't have to worry about which is the proper input or output or contacting the door manufacturer if you tie into the switches. It's a real simple, basic deal.
Is that DC?
What? No, I don't know. There's maybe AC. Whatever they're using, I don't use. Well, I don't. But I have a dry contact. You give me the power from whatever they supply, and that makes it. And that's another good point. Is some doors companies may be using AC. Some door companies may be using DC. Doing it this way, it doesn't matter what they use because you're sending their power source back to them.
I'm working on right now. It's got DC, AC, and 110.
Okay.
I got 3 different components out.
But that's what I'm saying. If you use the buttons, okay, they only have one power source to the buttons.
Right.
If the buttons are working and you use the power, if you run a 3-conductor cable over there and you tie into their common, and their common wire can be found very easy. It's the one that jumps between the 2 buttons. That's their common. Tie into there, come back over here and tie into my common. Okay, and then where the button is for the open, just run a wire over here, and where it's for to close it, run a wire over here. When this is called for, when the temperature is called for, I will pull in this relay. What will happen is the power from that box will be on COM 1 for that door, for the entrance door. Let's talk about the entrance door only. So you're going to have power going to COM 1, and if you trace this wire back out, it comes over to here. When it's called for, the relay will be pulled in, making contact, and allowing the power to go from COM 1 out to either output 1 or 3. If it's 1, it may open or shut. If it's 3, it would open or shut. 1 would be opening exit door. 3 would be closing the exit door. On every door, you will have a decal that tells you the computer component as well as what input and output it does. And so if you have 3 different powers and the doors are operating right now, it doesn't matter. Just whatever they're using to make their switches work, bring that over here because we're going to send it right back to them. Because when you press that button in, all you're doing is closing that contact, and we're going to simulate the exact same thing. Just we're going to do it electronically. And that's why we did it that way, is it was simple. It was very simple. That is basically it. We've gone over the 12.3 that supplies power out to the gantry, 24 volts, AC power to the gantry. We've gone over tying in the doors, the treadle switch, the spot prevents, the timers, the scrolling sign, and an auto cashier.